see hundreds of problems to be proficient at the chain rule, okay? So here we go. The chain rule, the reason it's called the chain rule is because it could have 2 links. A chain could have 3 links, 4 links, depending on the complexity of it. It could have multiple links, multiple steps, okay? So here's the main definition. The derivative of the composition of functions. For example, this one only has 2 links in the chain, okay? Is the derivative of the outside function only. The inside does not change. Times the derivative of the inside, which is g prime of x. So this one has 2 links. So one thing you have to get at, the first step you take the derivative of the outside, the f, the inside does not change, and then you take the derivative of the inside. An example of this would be this one, sine e to the x. Would you agree we know the derivative of sine, right? But we don't know the derivative of sine to the ex. Here's another example. Two x squared plus 3 to the 5th power. We don't know the derivative of this, but I do know the derivative of this one. So what I can do next to it, we know the blue ones. The derivative of sine is cosine. The derivative of x to the 5th is 5x to the 4th, right? But as soon as it's a composition, as soon as it's made out of more than one function, we just don't know the derivative. We have to use the chain rule. Let's do one with 3 links. F of g of h of x. You guys want to predict it or no? No? F prime g of h of x. So I took the derivative of the outside. So this guy, the next one on the agenda is g, so g prime of h of x. And the last one would have to be h prime. So this one has 3 links in the chain. Okay, I could do this for a while. We can do 4 links, 5 links, but it's all the same. So let's move on to examples here. We know the derivative of x to the 5th, the 5 comes down, x to the 4th. So this one, you can see, has an inside function. It's going to require the chain rule. The first step hasn't changed, though. The 5 is going to come down, parentheses, 3x squared plus 3 to the 4th power. And now I'm ready for the derivative of the inside. What's the derivative of the yellow? 6x, right? So 6x. You can put 6x or 6x in parentheses. We can simplify later. We're not going to simplify anything until we start consistently getting the right answers, okay? Good so far? Some of you guys are thinking, well, this is pretty easy so far, right? What tends to happen as we move forward, though, we'll see the product rule, and somewhere in the product rule, you have to do the chain rule. So there's so many combinations. That's why you really have to see hundreds of these. So we're going to first take the derivative of the outside function, which is negative sine. The inside does not change, ever, times the derivative of the inside, The derivative of e to the x happens to be e to the x. So that's that derivative. Okay. This next one's going to have 3 links in the chain. Let's see if you can find all 3 of them, okay? So I'm going to color code things. I have to take the derivative of ln, and I'll even write down the rule if you forgot it. The derivative of ln of x is 1 over x. So my first step would be 1 over sine pi x squared times. So I'll put a little check mark. We took the derivative of ln. The next guy on the agenda is sine. What's the derivative of sine? Cosine. The inside does not change. Pi x squared times. And I'll switch to my last color. Who knows the derivative of pi x squared? 2 pi x. So that one had 3 links in the chain. Yes?
Can you just go over how you got from L to the
Mm-hmm. The derivative of ln is 1 over the inside. And the inside was sine pi x squared. So that's why it's 1 over. X times the inside?
And you did sine, you switched it to cosine, and then multiplied that by what was inside of it. So you have 1 over x, and then multiply that by what was inside of it.
You're seeing there's an x, so it's ln of the inside. All of this is the inside. If you're wondering where are we on the scale 1 to 10, we're at a level 2 right now. Okay? Yeah, so we're going to have to see a lot of examples. Can I go to your slide? Okay, so with this example, we're jumping up to level 6 already. What do you think the start of the problem is? Huh? I wish. No. I'll stress it with this dot. Maybe this will help. Product rule. And somewhere along the product rule, we're going to see the chain rule. Okay? Are you going to be good at this day 1? Probably not. Day 2? No. But by the 3rd day, you should be making serious progress, okay? So here we go. The product rule, we say first or the second or the first, right? So first, derivative of the second. So the derivative of the second with like a brand new pair of eyes, or imagine nothing else exists. You're not gonna do that? I can do anything I want, people. What's the derivative of sine? Cosine. So it's going to be cosine. The inside does not change. Times. What's the derivative of e to the anything? Same thing, e to the anything. So e x squared plus 3 times. So if you're a little bit lost, we took the derivative of sine. We took the derivative of e. What is the derivative of the power? 2x times 2x. So there's the chain rule in the bracket. First derivative of the second plus the second times the derivative of the first. The derivative of x squared is 2x. Mhm. Okay, this is where you're going to try your first problem on your own. I will tell you it's controlled by the product rule because it's sine x squared times cosine. So your format will be first derivative of the second plus second derivative of the first. Give it your best shot, and I'll show you the response in a little bit, okay? So if you forgot the product rule, it goes first derivative of the second plus second derivative of the first. So I will say it as I do it. First, derivative of the second derivative of cosine is negative sine, plus the second derivative of the first. So it's this one that requires a chain rule because we only know the derivative of sine. We don't know the derivative of sine x squared, right? Okay, so derivative of sine is cosine. So in here, it's going to be cosine x squared times, what's the derivative of x squared? 2x. So that's the answer. Can we simplify? Yes. Are we going to right now? No. And I think I told you why yesterday. If we can't generate the first line, there's no point in simplifying. At what? Subject line? Oh, simplifying. Okay. Next, I'm going to start pulling problems from the homework. You're going to do them in your notes, and if you get stuck on the homework, you can see if we did it in the notes. Next to it, do you want me to write down the level of difficulty or no? This one's controlled by the power 3. So, so the 3 would have to come down. Times the derivative of the inside. And notice, this is something I'm going to keep mentioning over and over again. You have to be trained where to look. You always look at the original problem, okay? You never look at what you're creating, because if you're looking in the wrong location, you're going to do the chain rule too many times. You'll make it longer than it needs to be, and it'll be all wrong, okay? What's the derivative of the yellow? 2x minus 1 is what I heard. Is that right or wrong? Did I purposely make a mistake, or is it right? It needs parentheses. The chain rule is times the derivative of the inside. The derivative of the inside needs to be in parentheses. Okay, let's do one just like that. This one's at the same level, okay, number 9. What's the answer? It's right here. Okay, try number 9. Still level 1. I can already see some people are getting consistent results, which is good. Questions on part A or B? A or B? B. So I'll highlight it. The derivative of the inside is this guy. The derivative of 2x is 2, and the derivative of x cubed is 3x squared. Okay. Let's move up to a harder level. I'll show you something that we might have even seen on the big review packet. I mentioned many questions from that big review packet that we spent a lot of time on. Someone had already done the calculus step, and then after that it was all algebra 2. So we're at the point where now you can do that big calculus step on your own, okay? Do you guys want a hint on this one or no? No hint? Okay. What is the level? We're definitely at a level 6 again. I'm going to pause the video so I don't just... Oh, this was controlled by the product rule. Here's the answer. The first through the second is controlled by the 4, so 4 t cubed plus 1 to the third times the derivative of the inside, which is 3t squared, plus, so right now I just did first or the second, plus the second derivative of the first. The derivative of the first is controlled by that 3, t to the fourth minus 1 squared times the derivative of the inside, which I'll do in blue, 4. Come on. There we go. 4t cubed. Okay. From here, we do have the skills to simplify, but I need to make sure we practice this, okay? So before I move on, any questions on part A, B, C, D, E, or F? Yeah, F. So I took the derivative of this guy, and it lost the power, and then I took the derivative of the blue, which gave me 4t cubed, the derivative of the inside. Okay, all these are coming from your homework, so when you get stuck on your homework, look at your notes, see if we did it. Let's do one at the same level, okay? Number 19. I'll pause the video again. So first, derivative of the second plus the second derivative of the first. Questions on A, B, C, D, E, or F? Yeah. Uh-huh.
Right, so I wrote that as 1 over 3,
1 over 3.
squared, 8x squared minus 5 plus t to the second.
To the second power?
Second,
Why to the second?
because it's positive, so you add it 1. Or you subtract 1, making negative 4, but separate 1 over.
But then wouldn't the power be 4 on the bottom? Because you said it was 1 over blah, blah, blah to the second power on the bottom, but it should be to the fourth power on the bottom.
It becomes the exponent goes to positive.
Mm-hmm. But it becomes a positive 4, not a positive 2.
I was thinking it before. He had 1 over 8x
squared minus 5.
Oh, you rewrote the original problem. Is that what you said? And then took the derivative?
Instead of doing like that,
Uh-huh.
negative 3 up front, or negative 4x
Uh-huh.
1 over.
What? If you put it 1 over, did you use the quotient rule?
No, like the
Yeah.
negative 3.
Mhm.
Instead of doing the negatives, I put
Can you tell me exactly what to write? Okay.
1 divide there we go. 3 parentheses
Mhm.
ax squared times 5 parentheses squared.
Because if you moved the 3 to the bottom, it became a positive 3, and you subtracted 1
Well,
from
you don't
3.
move the 3. Yeah, negative
Yeah,
3.
that's why I was asking if he did it. It sounds like he did it prior, which you had to use the quotient rule then.
There should be a constant staying.
So right now it's set up as a product rule. If you rewrite the original as a quotient, you can get the correct answer using the quotient rule. But he moved it down and then took the derivative of the bottom, so he's not using the quotient rule when you should have been.
So we just have to keep this one.
Yes. Yeah. Yeah. If you want it right as a fraction, you would have to use the quotient rule. Now, we do have to know how to factor this. So we're going to end up here. What can I factor out of everything? I don't know if you guys see this. What number is this really? That's a negative 48. And what number is here? 8. So what comes out? And the 8. And 8 comes out. Next, I have a single x here, but I don't have a single x anywhere on this side, so no x comes out. So I always go in this order. I do constants, monomials, binomials, and if there's a trinomial, a trinomial. So I just did the constant, 8. There are no single x's that both sides have. So let's move on to binomials. How many of these guys can I pull out? Always the smaller value, 3 is correct. 2x minus 5 to the third. How many of these can I pull out? Remember, it's always the smaller value. Who's smaller, negative 4 or negative 3? So negative 4 has to come out. We did this on the big review packet, okay? We repeat the process. So if you remember, this negative 3 and 16 were really negative 48, and I took out an 8, what's left behind? Because 3 times 16 is 48. But a times b times c is also a times c times b. The order doesn't matter, right? Negative 3 times 16x is also negative 3 times x times 16. It's also negative x times 3 times 6. They're all equal. They slide. Yeah, the x is going to go in the inside. We're not there yet. I was only asking about the numbers. Hold on. We'll get there. We'll get there. We've already done it. We're just going to review it now. Okay, so let's backtrack. 3 and 16 is 48, and on the other side, 2 times 4 is 8. We were only able to pull out an 8, right? So what's left behind? Yes, negative 6 is left behind. Yes, but we're not doing the x. We always do the constants first. Now we'll do the x. So Santiago. So now we're going to move on to the x. Look at my list here. I did constants, so now monomials. You're right. There is an x that did not leave. You were just one step ahead of me, that's all. Yeah. That's what I was trying to tell you. Okay. Okay, next, you can see these don't match. We pulled out 3 of them, but there was 4 originally. So how many are left on the inside? 1. 2x minus 5 to the first power. These do match. So we have none of those left behind. And that concludes the first grouping. I'll copy and paste the plus sign. And we repeat the process all over again. We're going to go to constants. I had an 8. Did an 8 leave? Yeah, so I have no more constants, so I'll put a check mark. Monomials, do I have any extra x's lying around? No, so that's done. Binomials, so now these don't match, right? And we did have a strategy on figuring out when they don't match. I'm definitely guaranteed 8x squared minus 5 to some mystery power. Do you guys remember how to find that mystery power? Because we did talk about this a lot. Subtract the original one. The original one, I'll even do it down here. The original power is negative 3, and we always subtract what? What we're taking out, negative 4. And I even mentioned 90% of the time it becomes the number 1, right? So what is negative 3 minus 4? 1. So this mystery power is 1. And then, how about this one? Did all of those leave? So that's it. That's the hardest part. From here, you would simplify the inside, which is much easier, and we're done with the problem. Okay? Tonight's homework is just to do the first step. If the first step is right, try and simplify it. If the first step is wrong, look at the answer, well, see if you can fix it, okay? So I cannot use Rogowski. Rogowski asks the same question over and over again. So it gives you the impression, oh, I'm really good at this stuff, but you never get to see real questions. So we're going to use this PDF that comes from the black book, but I have the answers also, okay? So you'll have the problems and the answers, yes? You got cut off. Yeah, that was a bad copy because this PDF was missing that section, so we had to hand copy it. This one you can see is a perfect digital copy, so that won't happen, okay? So you'll see this PDF, the homework will be online. Just try tonight, try to do 7 through 20. If the first step is right, then try and simplify it. If the first step is not right, then definitely try to figure out what went wrong, okay? So the homework will be larger online, but just try 7 through 20 today. Yeah, 7 through 20. Stop.